Hi, team. Very good morning and good evening all. So let's get started, guys. Okay, so we were just started understanding about the foundation of the Python programming, or in general, the foundation of programming we were learning in the last week, right? For about 3 days or whenever, right? Uh, yeah, for nearly 3 days, we were started discussing about the Python and what is Python is all about at the high level. We understood, right? It's an interpreter based or intent based or high level programming language used for general purpose programming, right? Each and every word has a big meaning in the behind. The intent based or interpreter based means what? We were able to get some idea earlier by comparing with the compiler and the interpreter. We were able to understand what is an interpreter based language is all about. The high level language is all about what it says. We are not going to write huge number of lines of code for achieving some functionality. We can achieve the functionality in a very short way by using the existing functions. Okay, maybe we can realize this high level functionality, the high level feature of Python, by using some quick functions to achieve the result. Okay, that we'll be subsequently learning when we go more into the function based programming in the near future. But Python is a high level programming language. Everybody prefer going with high level rather than going in a low level or in a boilerplate coding fashion. Like basically, the high level represents what? The opposite of high level is low level or boilerplate coding. Python says, I'm a high level programming language because I support function based programming. Already everything is built in a form of function. All you have to do is just understand how to call the functions by passing some parameters. So that is what, even in our fundamental learning, we are going to learn about what is functions and I mean, I'm not going to deep dive into the function, how to leverage some built-in functions to achieve some quick functionality. That is what I'm just going to quickly cover with you guys with respect to the data types or with respect to the variables that we are going to use. Okay, so Python is a high-level programming language, not a boilerplate coding programming language. The boilerplate coding or a low-level programming language says what? In order to achieve some functionality, we have to write huge set of lines of code. But Python says you can just write 1 or 2 lines of code to achieve whatever the functionality that you want. So as like how boilerplate coding means what it represents. In our car, we have a bonnet. When you open the bonnet, we'll be having the bonnet plate is very hot. It is boiling. It has the I mean like huge heat in that engine, right? Rather than standing and working in the engine, you can sit in the inside the car and operate the vehicle. For example, if you want to switch on the car, we can sit in our driver's seat and we can switch on the car by putting the key, rather than going to the engine and pull some knob and all to switch on the engine like how traditionally people were doing. That is what the high level programming language represents. And Python is a general purpose programming language which is being used for multiple purposes. What we understood over here in our points, actually, like why we had to go for Python, like a couple of things we were going over here to understand, right? Why we have to go with Python programming language, to perform lot of activities where Python has a huge support with other frameworks. With any other tools, we can able to use Python more efficiently. So it's a general purpose programming language with a lot of inbuilt libraries are available. So people are prefer to use Python. Like we have understood couple of um, things about what is Python is all about and history when it got implemented and why we had to go with Python, right? Not only for this reason, right? We have a lot of other reason why we had to learn a programming language, and why I'm showing this again to you guys to ensure you guys have at least gone through this once for your realization, for your understanding purpose. We understood about why we should not have a fear of programming, right? Until you try, you will get the result, right? The more you try, the more you get the result, right? So that is what the fear brings to you. The fear is a positive factor in one side because the fear will make you leads to success. What I was concluding that day, and we were understanding about the compiler versus interpreter based programming language, right? Python is a interpreter based programming language. What it says, Irfan, when you pass a complete code, when you develop and when you pass to our Python interpreter, what it will do, it will take each and every line of code and compile it, convert it into some bytecode format or into some binary format, what the system can understand more efficiently. Then that code will be passed to the Python virtual machine, right? The Python virtual machine will process that code with the help of maybe like the RAM, the processor and everything. And then the result will be produced. But each and every line of code will be undergoing this cycle. Whereas if you go with the compiler-based language, the compiler-based language will expect all the code what you are going to compile, and it will take that code in one shot and get it compiled and convert it into a bytecode, into the binary format. And then that code will be stored as a compiled file in a name of .class file or in a name of .jar file or whatever. So that compiled file will be loaded into the Java virtual machine, like be it Scala, be it Java. The Java virtual machine will be loading that code, whatever the compiled code, and the compiled code will execute and produce the result, everything together. But when we do a compiled, when we use a compiler, the compiler will say what? Hey, Irfan, I'm going to compile the code once for all. If you give the input of the entire code, I'm going to take the entire code and I'm going to perform an operation on that code once for all. Maybe I can use some memory container and all for doing that activity. Once I create that bytecode, once I have the bytecode created or the maybe compiled code created, which is understandable by me more efficiently, I'll store that into our disk in a form of maybe .class or .binary or .jar or whatever the name. I don't bother which extension it is going to use. And I will be throwing error in case if any one of the line of the program does not meet my requirement, syntax or semantics. If it is not meet, I'll throw the error and come out without compiling the entire code. So after I do all this effort, I'll be producing the intermediate object code. When you go and execute that code, again, I'll take that code and put it into the memory, the Java virtual machine memory, and then I'll quickly execute that program without doing any compilation once again. I'll just run the compiled code again and again. If you have any changes made in the code, then you have to recompile that code. Otherwise, I'll be running the old compiled code only. By that way, the execution is faster in the compiler-based programming language, but whereas interpreter-based programming language like Python will be having the execution relatively slower. The reason behind, though you interpret the code for the first time entirely from line 1 to line 10 of the entire code block, again and again, you'll be interpreting when you pass to the interpreter, because interpreter will not generate any intermediate object code and store in anywhere in a form of .class file or in a form of .jar file or anything. The Python code will be executed as a kind of a raw code every time. And every time the code will be undergoing with the interpretation line by line. So the conversion of the high-level language to the internal low-level language, which is nothing but the binary format of the code will happen at line by line level. By loading that line into the memory, it will do that operation, and then it will produce the result then and there. In case any error occurred, in the 8th line, the first 7 lines will be executed. The 8th line, when it sees the error, it will come out of the program by partially executing the program, because line by line of execution is happening. Since Python is iterating every line by line of code every time, whenever you run, it is going to be a time-consuming one relatively. Whereas compiler-based code says what? Compiler-based system says what? Hey, I am a programming language where you can compile the code once for all, reuse that code again and again a number of times by having it run much faster, because I don't interfere on that code again and again. I don't validate the code. I don't do the compilation of the code and convert that code in a native format, not in a native format, in a binary format what machine can understand. I don't do it again and again. I do it once for all. Despite Python falls under the interpreter-based programming language, despite we have that maybe what to say the drawback in Python, Python is being widely used in the market because of performance-wise, Python is relatively lesser, but memory management and all, Python is good actually for that reason. So we need less memory, less resources, but the execution of our code will be relatively slower, but we need more resources for compiling the code, for loading the entire code base into our memory, but the execution will be faster in the compiler. Despite we have this challenge, right? Python is being used because of more business outcome I can produce out of Python, rather than considering the performance. Okay, great. So you guys were able to understand this interpreter versus compiler by executing some code base I have given you guys, right? So that one, if you do very clearly by connecting these dots, connecting this whatever the line by line of instruction, right, what has been given here. For example, you're going to have an entire code taken as an input, and you are going to get a object code produced as an output. For that, what you do, you will be passing that to the compiler. The Scala C that I type. The Scala C will do what? It doesn't need to compile every single time, just once. So it is going to do a compilation once for all and produce its class version of that code. By loading that into the memory quickly, it will go and produce the binary version of the code in the hard disk. If in case any error we have, it will throw the error and come out without compiling. So by that way, the first step is input. Second step is the workload, what it is going to do. By using the memory, it is going to produce the output in a binary format by checking any errors are there. So all this 1, 5, 4, 6, and 2, all these steps are completed. Once I complete generating the binary code, the object code, all I am going to do is what? Run that code by saying Scala, that object name. It is going to again and again run much faster without again and again compiling. It won't take the same time for initially compiling the code. Initially, it takes some time for compiling the code. If you guys realize that, well and good. That gives you a one-time understanding of what is compiler. That helps you in a later point of time to explain to anyone what is a compiler is all about. And you have an understanding of, hey, what is a compiler and interpreter? I had some theoretical understanding so far. Everybody knows compiler means it compiles the entire code. Interpreter means it interprets line by line of code. But the way how it operates, not everybody are aware of, or not even one person aware of that, like by trying this out. But we got an opportunity to try this out. Once you guys go and literally try it out and make your hands dirty, you'll be getting an idea of what is this all about, right? Okay, so just I'm recalling this because of whoever did not try, you'll be going and trying. For that reason only, I'm talking about all this again. Otherwise, I might be going to the actual topic of what you're supposed to discuss today, right? Fine. And you were able to understand this execution model of a Python programming also. In this place, if you notice very clearly, the compiler is there, even in Python also. Without compiler, nothing will work. But the compiler is going to happen. The compilation of the code is going to happen. Compiling means what? Conversion of the code into some binary format, some format what the system can understand more efficiently. That activity is happening in Python also. But line by line code, line by line of compilation is happening in the Python side because of the interpreter. The interpreter says, I will interpret one line of the code and I'll pass to the compiler. The compiler will convert that code into a binary format. That binary code will be sent to the Python virtual machine, that one line of code, get executed, produce the result, check for error. If error is there, it will come out. Otherwise, it will just get executed. Then the second line will be taken from the source code. Whereas if I put a compiler diagram over here, what I do, the entire source code will be passed to the compiler. The entire line of code will be passed to the compiler. The compiler will load that code into the memory, the Java virtual machine memory. And the Java virtual machine memory will be converting that entire code by evaluating it, whether any errors are there or whatever, and convert that into binary code and store that binary code in the disk. Then again, when I go and run that binary code, the binary code will be loaded into the Java virtual machine fully and then get executed and produce the result. So it's a two iteration I'm doing. One is for compiling, one thorough iteration. Then for execution, I'm doing again and again execution of the same code a number of times, which is in a binary format. Here I'm generating the binary code for every line and then getting executed. There I generated the binary code for the entire program once for all, and I'm executing it a number of times whenever I want. That makes the big difference between the compiler-based and the interpreter-based languages. What we understood. And I told the function-based programming concept we'll be learning, but not right now. We will be seeing some, inclusion of the function-based programming, some essence of function-based programming. We'll be seeing, but not fully, not in that mode. We are going to learn the function-based programming yet. In a formal mode, we are not yet learning. We will come back to that part, and we started our life with variables. Every programming languages that if you want to learn, you got to start with some nitty-gritties of understanding the programming language, like how to comment, how to do indentation, or how to create a block of code, right? Like how to take the input, how to produce the output, right? Like some of these concepts we are all supposed to understand. So that is what we understood predominantly in the nitty-gritty of programming. Then subsequently we leads towards the variables. So if you go through this entire code base, I have kept it in a day-by-day fashion, and I'm expecting you all to complete this day-by-day exercises then and there. Otherwise, you will be never doing any Python programming. I'm sure about it. Okay. So if you guys follow all this model of I'm trying to help you guys achieve this, if you do this, I'm well and good. Okay, or everybody will be well and good. So variables we were understanding. Day 2 we were understanding about the variables and its properties. So variable has some properties like dynamic inference property, dynamically typed property, and the strongly typed property. There are few more nitty-gritty properties are there. Duck type property and all is there. Fine, you can leave it for now. So we were understanding about the variables and its properties. The dynamic inference says what? I can able to identify the data type of a variable dynamically based on the value. Excellent. The dynamically typed variable says what? If you wanted to change the type of a variable, right? You can able to change it in a later point of time, right? You can change the variable in a later point of time, the data type as well. So assigning the data type dynamically, changing the data type dynamically. That is what you can say. Not assigning, changing the data type dynamically. Then the strongly typed says what? If I have some operation is supposed to be performed between two variables, between multiple variables, the variable should be of same type. The operation can be performed between the variables which is of same data type or same hierarchy of data type at least, right? You can say same data type very simply. Hierarchy and all you don't have to think until and otherwise if you learn about the data types separately. We have to understand the data type, then only you can know about what is hierarchy of data type. But until now, you can consider, okay, the strongly typed language says what? I can only accept operation between the corresponding data types, the respective data types, not between the irrespective data types, right? Not between the maybe like different data types, right? That is nothing but with respect to the strongly typed variable represents. Then we understood about some nitty-gritties of programming in terms of like how the naming convention of a variable has to be. The variable can have alphanumeric and a special character of underscore in it, but we are supposed to have maybe like variable with the name starting not with numbers, and we can't use hyphens or any other special characters, right? And we can use the variable names with maybe like a init cap or camel case or with underscores in between, right? All the possibilities we can use the variables with. It depends upon the people or the team or project who is using the variables accordingly. All are supportive. All are can be used, right? Variables must be started with letters only, not with any other numbers or anything. And then variables can contain only alphanumeric or underscores, right? And variables are case sensitive, very importantly. This doubt everybody used to get, whether it is case sensitive, yes, it is case sensitive, right? And then we were understanding about something called how to go with the type of a variable, how to understand what data type it is, and how to check what data type it is, right? And accordingly, I wanted to act, right? And accordingly, I wanted to change the type as well. If by using something called isInstance of function, we can able to understand, or by using the type function will print you the result just in the screen to say, hey, this variable is of this type. But isInstance will help you check whether the variable is of expected type. There's a small variation between type and the isInstance. The isInstance will help you check whether this variable is of my expected type. If it is so, then I'll be taking that variable as is. If it is not as per my expectation, if it returns false, then I'll be doing what? I'm expecting a variable of type integer. What I do? So I'll go and check isInstance of the variable a is equal to 100. I'm expecting a is supposed to be an integer, right? So I can do what isInstance of a. I will check whether it is integer or not. I'll check. If a is not an integer, right? If a is an integer, then I'll say, hey, it is integer. I don't bother. Nothing to do. If not, what I do? I'll try to convert that into an integer. So print of converting to integer. I use the format function to say convert this into an integer. So int of a, I'll say, right? So it is converting that number into an integer type and doing the activity. So I got the a, converted into integer. Unnecessarily, I don't write this integer of a. Until and otherwise, if it is already it's an integer, why I have to again convert? I don't do that activity. Okay. So this is the typecasting, and so we are doing all the things here. We want to check the type. Just we can type of a. It will show which class it is belonging to. But I want to check whether it is of this class what I'm expecting, a program of what I'm expecting. Then I'll be checking using an isInstance function. Based on the result, I will go and decide on applying whether the typecasting or not. Typecasting I'll apply based on my isInstance result. Whether the isInstance results true or false, accordingly, I'll go and act. Since it is returned false, the if condition will take me to the else case. And the else case, I'm going to run some operations to convert the type into a different type of whatever I want. Okay. So if you want to operate between the variables, we could not able to operate directly. So we have to apply the typecasting for overcoming the problem of what? The strongly typed feature of Python. Python does not allow us to operate between the different types. So I'm going to make all of them into the same type to get operated. What we understood, right? These are all the part what we understood. I was just writing something like here and there for your understanding purpose, right? Some simple code for understanding. By this way, you will be learning some conditional structure, how we write in Python, that we are going to learn formally yet. Okay. Input. How can I pass input to a variable? What we understood, right? Just by using an input function, it should be accepting the value in a string type. So I have to convert the type into a different type as per my need, right? By that way, I can able to operate on this value dynamically by passing as an argument, not as a direct argument. This we call it as a standard input we are getting. So this can be happen in some applications, some runtime applications. We can use these input functions, but not regularly. It will be used in a regular program. We'll be passing the values whatever we want to assign to some variables, or we wanted to dynamically pass some values. We'll be using parameters. We'll be using something called a parameter concept that will be using it in the function-based programming subsequently. Keep it aside. But however, we can take the input from the keyboard. We can produce the output in the screen, right? All the opportunities we have. So this is how we can pass the input as a parameter to the through the function to set it in a variable. But function-based programming, we are yet to learn. We are yet to learn formally. What is def? What is func? What is this variable that I'm passing, right? So what is the scope of this input argument? Like a lot of things we are yet to learn, right? Okay, fine. Day 3 learning is all about what we did is, we understood about some foundation of programming. We just directly understood about what are all variables. We dedicatedly take a day of time to learn about variables means what. And we still continue learning variables, use variables forever throughout our programming journey. Then we learned about like Python is an intent-based programming language. Why indentation is needed? We had a lot of story to discuss here. Why indentation is needed? For clarity, for managing the code more efficiently, right? For having a better clarity of using the program, right? Other programming languages does not expect indentation as a mandatory step, but whereas Python expect the indentation as a mandatory part in the programming, the reason being Python use indentation for blocking the code, for creating the block of the code. No need of using do or done or if and fi. No need of using open and closed flower brace. Nothing we have to use. We can get all of them achieved by just having an indentation. The indent has to be are not always mandatory to have 4 spaces, but if you have 4 spaces, the indentation looks good actually. That's the reason. That's the reason we go with 4 spaces used for indentation, or we can use tab also for indentation. Everything works. Okay, and indentation has to be uniform across all the lines of code that is used inside the block. Across the block, it is fine. Across the block, in this block, we are using a tab as an indentation. Here we are using space, which will not work. But if you use tab or space or tab across every lines, then it is okay. Any one of the indentation model we have to use. And we can use in one block, maybe one indentation model, and in the other block, we can use some other indentation model in the same program. It works. It won't expect across the program. Only within the block, it will expect the same indentation levels of usage. Right? Great. Comment in Python programming language, we can have a single line comment with hash, multi-line comments with 3 single quotes or 3 double quotes we can use. Python treats single quotes, double quotes, and triple quotes in the same way almost, right? Even we were saying about the usage of triple quotes also. All the 3, the Python will treat it in the same way, right? We can assign a value something like this. A comma B comma C is equal to, I can assign A with hello, B with hello, and C also with hello. All are same. A is also going to print, B also going to print, C also going to print the same result, despite I use single quote or double quotes or 3 double quotes or 3 single quotes, everything operates in the same way. And we are understanding the variable assignment can happen in one line itself for all the variables that we want to assign. We don't have to separate type. A is equal to hello, B is equal to hello, C is equal to hello. We don't have to type. Some nitty-gritties like even I asked to try out in our exercise, right? You guys are, I hope you guys are trying it out. I'm not challenging with any programming over here when I give you in the use cases, in the scenarios. I just wanted you guys to just try it out. I'll give you some use case that is a different story. Some challenges I'll give you guys. But for now, you can just consider this as a regular use cases just to try out something additionally. Okay, you will be getting some interest in programming. For that reason, I just given you some simple scenarios over there. Okay, standard output options in print statement. So how can you use print statement? In multiple ways we can use print statement, what we discussed. Printing off, print can be passed with multiple arguments. Print can be passed with single argument, which can be concatenated together. But when you concatenate, we have to do an operation of, for example, I can just do a print of A plus B plus C. We'll do what? It will print everything as one argument. It will take everything as a one argument and get it printed. Right? We can just go and say, print some string along with this value passed as a format model. There is a function called format function we have. On top of the string, we can apply that format function to go and pass this as an argument as $0, $1, $2, like that. For example, if I want to pass A and B or A, B, and C as 3 arguments, I can pass like this. So it is printing, not dollar, sorry. Open and close flower brace. Dollar is with respect to the Linux programming, right? Sometime we may get a conflict in our brain to use the notations and all across the languages. Sometimes Scala will come and impose here in Python. Linux will come and impose here in Python, or I mean like that maybe like characteristics you may get naturally, right? So we are getting the result like all the 3 parameters are passed over here, or we can use some option like the formatted string option, where you can use the variable name itself directly. Variable name itself directly, right? This is what the way how we can do a output production, right? Standard output option, standard input, standard output we have realized, right? These are all the possibilities what you have seen. And the variable properties like mutable and immutable properties we were seeing. And we have the chart over here. That is where I told the purpose of our chart is for what reason. out of all the data types what we have in Python, right? We have list and then the set and then the dictionary. These three are only mutable. Rest of all are immutable. We can't change the values what has been assigned. We can only maybe like redefine or recreate the variables by doing the operations. We can't modify the existing variable by performing the operation of changing it, right? So by that way, we have a variable like with the string is immutable. I was just showing you an example. I was having some string and I was showing you why string is not mutable. So why string is immutable? When we try to change something in the string, it is not allowing us to change, right? But list is allowing us to change. The element of the string is not allowing us to change, but the element of the list is allowing us to change. And you are learning one more important factor, like if I have a string in a variable assigned, we can able to take some element of that variable, right, by putting the index. String also has indexed sequenced collection of characters. So that understanding you guys have got, right? Fine. So these are all the things what we learned so far. So let's enter into our day 4 learning. Maybe all these topics are bigger topics, actually speaking. So the data types I am going to cover with respect to simple data types in Python. Complex data types will be covered in a separate day, in a separate topic, okay? Complex data types of list, set, tuple, dictionary. These 4 are the major complex data types. In the order of importance, I can put list and then dictionary, which is secondarily important. Tuple is tertiarily important in the order of importance if I write. Set is very least important. These 4 data types we'll be learning subsequently. We are going to learn about the simple data types right now. Okay, what are the simple data types that is available in Python? Okay, there are a couple of simple data types are available in Python. In the numeric data types, we have integer and float. In the string data type, we have string str. We have something like maybe like Boolean data type. These are all some other data types like Boolean. We don't have date data type as such. We have date data type in Python, but not in the native library of Python. It is available in the special libraries of the additional libraries, the date libraries we can include. But as such in the native library of Python, we are having these data types available, which I have listed over here. Let me go to that. Okay. If you use some additional library like pandas library, we have date is available. If you use additional library, something like a Spark SQL, we have lot of date functions available. What we wrote in the date function in our Spark is not Python core library. We are talking about the Python core library, the Python core program. Okay, Boolean. And then we have something like bytes. We have bytes function. Like these are all some of the nitty-gritty functions what we have, right? Apart from this, maybe like, yes, these are all the, I mean, like regular are not even regularly used data types. The regularly used data types are numeric data types like the integer, complex number, and float. Maybe complex number is also there. Exponential numbers is also there. Or complex numbers is also there, right? And then we have the sequence type where the string will be falling under. String has even sequence of values. Say we are seeing string as a normal simple data type. Actually, the string will go into both simple data type and the complex data type also, because it falls under the sequence type. Indexed sequenced collection of values the string will have. So we can treat string as a normal string, literally as a literal string, but it has internally some indexes, and we can able to iterate on the string all the features we have in the string, because string falls under the sequence type. And then we have Boolean type. we have something like, like bytes type, binary type. Bytes is nothing but the binary type. Like we have a couple of types available to play around. And we'll be using more number of types, not in the core Python, in our respective frameworks where we are going to use. Those additional libraries will give you a lot of, or all type of data types what you expect, like a date or timestamp or any other data type that you expect. Okay, but fundamentally, these are all the data types what we have, we can play around. Okay, so I can assign a variable with a type for my understanding purpose, for my identification purpose. I can assign a variable, something like variable A as colon mentioned with what data type I want to mention. So integer. So I'm going to say the A is a variable of class integer. C represents a class. V represents a variable. F represents a function. M represents a method. So I'll be parallelly teaching you guys here how you can simplify your life. See, not everybody can able to recall everything, right? And not needed as well. No need to recall everything. Whatever we regularly use, you can recall, and you can automatically, naturally, when you try again and again, it will automatically come to you. Naturally, it will come. But apart from that, you have a lot of functions, lot of notations and all available. How we can realize them? When you use it regularly, you can get it automatically without you try to realize it, try to recall it. Naturally, your brain will recall it. But certain cases, we don't have to worry of recalling, but we have to know how to use it by understanding the documentation, by understanding the suggestion what they are giving. So it says there is a built-in functions or built-in class, what we have built-ins, what is mentioned here. Something is mentioned here as string to print. This one we have kept it in the top, something as a variable created in this local environment. So it varies based on how we are using. So int is a class. I'm telling, create a variable A of type integer. Assign some value of type integer. Like this, I'm telling. This is the completion of this integer type definition. But because of Python has the characteristics of dynamically or dynamic inference property, whether you define it as an integer or not, based on the value what you assign, it will treat this type accordingly. For example, if I'm going to assign 100.10, if I'm going to define this as an integer type, the type of A is going to show what? Integer or float? What is your assumption here?
Float.
The dynamically type dynamical inference feature will apply here. Though I say A is of type integer, I'm not forcefully telling you have to be a type integer. I'm just giving a hint saying like, hey, you can be a class of integer. But based on this value, it is overriding that integer as float. He's telling based on the value because of dynamic inference property, he's telling, no, Irfan, I'm going to make this as float. But I'm going to, I wanted to have A as an integer. Then what I do? I want to have A as type integer. I don't want it to hold the value of float. A has to hold 110, 100.10. A has to hold the value of 100.10. See, I'm just telling two things here to Python. What I'm telling, hey, Python, can you create a variable A of type integer? Okay, I'll do it. Can you hold 100.10 in your variable A? Like this, when I say, Python could not able to, Python has to accept any one of this, what you are telling. So Python will accept the second thing what you told by saying, okay, Irfan, I'm just negating this A equal to A of a type integer. Rather, I will take this value and understand this values of type float, and I'll assign float as data type for A. Like this, he will say. Python is telling, let me just take this value and understand the type of this, because I'm a dynamic inference language. I'm going to infer the type dynamically. Let me assign A with type float, despite you ask me to maintain integer. If I maintain integer, I can only retain 100. I can't retain 100.10. Like Python is very clear about it. Then if I want to say, no, Python, though the value is passed as an 100.10, you just consider it as an integer. I'll give you only the integer portion of it. I'll convert this type to an integer and I'll give it to you. You assign that value as an integer itself, how I assigned. Now what is the type we have? As you guys were mentioning. Now it is of type integer only. So we can create a variable with this integer type for your identification purpose. But depends upon the value that you assign, the type will change, right? In order to mention this, what you have to do is either you have to make it as int type, or you have to make a colon float type, and you can have 100 or 10 used. Any one of this you have to do to fulfill this. With me in this case, right? Okay. So integer type, float type, these two are the data type what we can use. Float is like a decimal value, whatever we are having. Complex numbers also we can have a equal to maybe like 3 exponential of 10. So it will go and store the values in an exponents. If I go and have 3 exponential of 100, it will go to even exponential value, like a complex value like this, it will be stored. 3 exponential of 100. So I just wanted to operate on it. I can operate with some other numbers, but it will store it in a complex format like this. So exponential values we can create. That is treated as a complex value. We rarely use this for holding very huge number values and all. Very not regularly used one. So float type we can use. Integer type we can use. Complex number we can use. Yes, that is a formula what Akhilesh, like in the mathematics and all we use, correct. Okay, so complex format we can use. Then what we have? Then we have something like a string type. String is a regular data type what we can use. So string is a sequenced collection of it. It is a, like a sequence type actually. Sequence data type. Though you treat string as a literal, it has a property inside called a sequence type property. So we can create a variable a of type str, right? Or I'm going to mention a is of character of that string type I can mention as well. The char type also I can mention, right? The char type we will discuss. So str type I'm just mentioning the string type, which is equal to something like this. I'm going to assign with single quote, double quote, or triple quotes or whatever. Right? So the string can be sequenced. We can able to identify the string with the index value, right? And we can perform some string operations in it. Lot of string operative functions are available. You can do what it will print. It will pivot, insert as and print. It will pivot, insert as and print it in a vertical fashion, right? So that proves the string is not just a simple type. Actually, I just put string in a simple type. Actually, it is a sequence type. It's a collection type. But we always treat string as a simple type everywhere. But actually, it is a collection type. Okay. By that way, it supports a lot of functionalities. That is what we are going to see over here for some nitty-gritty understanding, quick understanding. Okay. So these are all the data types what we have available, including some other data types. Some other data types like Boolean, bytes, none, these kind of data types are available. So let's go and deal about these data types, the other data types, miscellaneous data types. So we can have something like a Boolean data type. So a colon bool we have to give of type true or false. We can assign true or false into this. Basically, the Boolean type will be returned, not assigned most of the time. We can assign as well. When we may assign, For example, I'll assign a variable a boolean true. Okay. If I wanted to have something assigned as a true for my purpose of maybe like doing some operations. For example, if I want to create something called an infinite loop, one of the usage what I do. Why we are bringing not operator here, Lakshmi? No. Not operator, yes, you can use not of the true, it will become false. That is a different story. But not is an operator. We are going to see operators next. Now we are talking about the data types, right? Okay. So we can negate this Boolean as true or false or whatever. That is a different story. But what is the usage of this Boolean? We know the usage of string or integer or all these data types. But what is the usage of this Boolean data type that we have as such? Boolean will be mostly returned as a result for us. For example, as Prem mentioned, is instance of if I write, right, is instance of some variable as integer that I'm writing. It is going to return automatically the Boolean data type of saying, no, it is not an instance of integer, it is a Boolean type. It is going to say it is not, A is not an instance of integer. Automatically, you are going to return a false as a result. The type itself is returning. Okay. So maybe the number is not considered as a Boolean or I mean true or false or whatever. So A is a string or not. I'm just checking. It is telling no, A is not a string. It is false. So this is a return what I'm getting. So if I go and say type of this function, it will say I'm returning a type of Boolean. You're able to understand. So mostly the Boolean type will be getting as a return statement of a function. So this function is instance is a function which is going to take two arguments. One is the variable and the class type. It is going to check whether this variable is of this type. If so, it is going to return true. If not, it is going to return false as a Boolean type. So Boolean type, we don't basically assign like this in general, but in certain cases we can assign as well. In what case? If I want to have some infinite loop to be created, I want something to run continuously, right? Like you can consider something like a cryptocurrency generation and all they will do with the help of this continuous operation. Okay, they'll run infinite loop to generate the entire cryptocurrency value inside, but with the n number of iterations they do. So in that case, what I can do is I can write a looping construct while a, right, print maybe like anything that I want to print, right? Print infinite. In that case, I can use what? The, I mean like Boolean type. So while true, while this condition is true, you go and run this loop. I can tell like that. So this loop is going to run forever if I don't stop. Or if I'm going to mention a, print I mean like printing as it is true. So I'm going directly into the if condition without checking for anything. I want to just go and run this if condition for some case. So I'm saying like, hey, if true, go and run the if condition. This will help you understand a lot of things. How the if condition works, how the loop works. Until the condition is true, it is going to run this operation. Right? I want to just run if block. There is a huge set of code over here. I want to run that regardless of whether this is meeting or not. Basically, I'll check here something, whether this condition is met or not, and then I'll go and run the condition. But I'm not running the condition without checking anything. I just wanted to run these conditions, but by using the same if block. So I will go and directly close my eyes and give true here. So the usage of Boolean is naturally for returning for getting it as a return type, but we can use this Boolean type for our purpose of doing some infinite looping or unconditional conditional structure. Conditional structure is meant for checking for some condition and go and execute something, but I want to run it unconditionally. For those cases, bool will be used for usually return Boolean type. Functions return Boolean type. Can be used for unconditional conditional structures like if condition or for infinite looping. See, other types does not require maybe like what is the explanation. All are regularly used one, but these kind of types and all not regularly used. So I'm going to have the bytes type. So A is of some number, right? This number is converted into byte format. So I can do bytes of 100. So this value is converted into byte format. Can we have true or false in the same variable in Boolean? Why not? But both can be kept together. Either or can be kept together, right? So we can have the information stored in a binary format, right? The byte format we can store. This is the byte code, what our Python generates even, right? So I can have the data converted into binary format. I want to see this binary data in which memory address it is being loaded. So basically, when a value is assigned, I discussed about this with you guys. You remember? We can create a value assigned to a variable, or we can have a variable assigned with the program, the reference, right? You remember this, guys? Or I am yet to discuss about that. I did not find that in our discussion. Maybe I did not capture that in our document, it seems. So this part we discussed. A variable can be of reference or a value, what we discussed here, right? So now I'm having the value assigned as 100. I'm assigning a value as 100 for A, but I'm converting that value to a binary format, to a byte format, and I'm making this value stored in a binary format, in a byte format, in the memory as a reference. So A is of binary format, which is loaded in the memory. So I can go and do a memory view of this A. It will give me an idea of in which address this is loaded, in which address this data is loaded. I want to see in a memory view. If I want to store this variable in a memory address for reference, I have to convert that into a binary format. This will be naturally done by our programs. But if we wanted to explicitly convert some values what we have in a binary format and store it into the memory address for a future reference, we can convert this into a bytes format and do that. And we can do that. Okay. So just I'm putting this point, like these are all unusual functions, unusual commands, but unusual types, but I'm covering all the types, all the simple types, whatever Python supports, I'm covering them. Okay. What are all the possible types that Python supports that I'm covering? Okay. Bytes is used to convert a value to binary object and for reference or binary object that can be used as reference, right? We can use something like a memory view to see in which memory address this variable is being stored. It's been converted into bytes and stored, right? Just for your information. Okay, Tim. So these are all the data types, including one more important data type called what? None type. Equivalent to what? What type in our regular, maybe like learning? Null. Equivalent to null type in our DB or anywhere else you can consider. Everybody knows what is null. Null means what? None means nothing or unknown. Unknown. It is not no value. It is not no value. Maybe since I put nothing, you are telling like that. No, it is, don't say no value. It has value. But I don't know what value it contains. Maybe a best way to put is unknown. None is unknown. There is some value, but it is an unknown value. That is what none says. Okay. Null is a value. Okay. Null is doesn't mean like I don't have a value at all. Null means a value. None means it's a value, but I don't know what value it contains. It's like a garbage. I can't use it. But at times we may use none for our purpose. For our purpose. What is the purpose of having none? Let me tell you. Okay, let me tell you. Maybe we'll use it in our subsequent learning somewhere, the none and all. But I'll just give you an idea. So A colon none type is equal to none I'm going to assign. What is the meaning of doing this operation? You may say, Irfan, why we have to create a variable with no value? No value means it doesn't mean no value. It means none type. It has some value. It is not printing blank space. Blank space means you can say like none does not contain anything. It says none. None means I don't know what value it contains. Why we are doing this operation? Why we have to assign a value, a variable with some none value? Maybe for different reason we may be using this. I'll tell you one reason behind. I'm assigning a value, a variable which is unknown beforehand. I don't know what value I'm going to use for A. Yeah, as Prem is mentioning. I don't know today, right now, currently, what value I'm going to use this A for. This variable has to be assigned with what value, I don't know. I'm going to use this variable in a later point of time for some purposes. If 1 equal to 1, then assign A equal to 100. Else, assign A equal to 200. This is what I want to achieve. So initially what I'm doing is I'm setting A as none. After I perform this operation, I'm deciding A has to be 100 or A has to be 200. It holds a space, Mari. Empty, not empty, but vacuum value doesn't hold any space. Not empty, it holds a space. It holds a space for holding the null, holding the none value. Okay, it holds some bytes of size. None is not equal to none. What does it mean? I'm not getting you, Rajaraman. None is not equal to none. We could not able to compare none. We could not able to compare, or we could not able to operate none with anything. For example, none operated with some value. We could not able to operate, right? Okay, Python uses none too. Maybe you can kind of relate, but touch will create a zero file, empty file, right? The file name will be maintained, but not the value inside the file. But whereas none says what? I don't know the value, but there is some value. This A is going to have some value, or this A is having some value which is unknown. But this one we say what? Hey, this value is known. A is equal to 100, A is equal to 200. After I initialize with none, then later I'll use it for any purposes. If I don't use this variable initially, right? If I don't have this like this, if I'm going to directly create this variable here only, then the scope of this variable will be started used from here. For example, you think about you are telling I'm entering into a shop with this mobile phone. Okay, with this mobile phone, I don't know what cover I'm going to put for this. What back case I'm going to put for this. So we are going with the mobile phone, the variable with a value which is unknown, but you are going to put definitely a cover. After you go into the shop, you decide which model you want, then you can apply that on top of it. So the none will be replaced with the 100 or 200 or whatever you are going to use. Following me? If I don't have a placeholder in my hand, first of all, if I don't take this mobile, if I don't have a plan of putting a cover, then we can directly go and create A and B, but we have something to be done, but not now, in a later point of time. In that case, we can have the value none assigned, or none will be naturally creating in case if the value is not available. For example, if you are going to take some data from a database which contains null, you are going to convert that into a Python variable, Python value, it will become none. Following me, team? None is not equivalent to string. See, guys, people always make this mistake, right? What mistake? I have A none equal to none. Did I put it in a double quotes like this? Right, this is a big mistake everybody do, even in databases. They compare something like this. Even I mean, like my team members do this. They write a query like saying select star from table name, where some column they are expecting null value. What they will type, where some maybe like employee ID equal to null, like this they'll type. Is it correct? If you treat this null as a string, if you treat this null as a string, first of all, null can't be compared with anything. Null can be only checked. So is null I'll be checking. Is null is the function what we use, rather. You remember? Why we use specifically for I mean, like databases, it is applicable for Linux also. I mean, for Python also. If I create like this, both are same or different. If I just print A, it is showing me null, or print of A if I do, it is showing me null, none. What is the difference between this print of A and this print of A? Right? The above none is not a string. The above none is a literal none. We could not able to apply the string function on it. It is a none value. We can't able to apply functions on it. Unknown value, what function you will apply? For specific to string, there are some functions available. For specific to float, we have some functions available. Specific to numbers, we have some functions available. None. Value itself unknown, then how can you apply length function? It is asking. You got it, Akhilesh and everybody? So it's not like none has to be considered as a string. Not correct, right? That people as a mistake and do a mistake. If you put it in a single quote or double quotes, it will become a string. But this represents what? Some string value we have. But none is not a string value. None is an unknown type, unknown value. Type of none, right? We don't know. It's of none type. It's an unknown type. Okay, fine tip. So none is used for, or it's a null type in. So none is used for maybe like future, purposes as a placeholder. Okay, if 1 equal to 1, then A is equal to 100. Then always A will be equal to 100. Yeah, see, but what's the use of none? No. See, I'm just writing some condition, right? So my mobile case is equal to unknown for now. I'm entering into the shop, okay? I'm entering into the shop. Price I'm having in my mind. I'm going to buy a mobile case for 200 rupees maximum. If the product number 1 I'm taking in my hand, product 1 price is equal to be maybe like 150 rupees. Okay. I'm going to check if product 1 is less than or equal to price what I have in my mind. Then I go and apply my mobile case with maybe like that particular product 1 case. Yes, I'll go with my mobile case with product 2 case or whatever, some other product case. Understood now, Vignesh? So now what is the value of my mobile case? I just went with none, unknown value. Now I have the mobile case with prod 1 case. With me, Vignesh? I put 1 equal to 1 just for an understanding purpose.
Okay.
You got the point?
Yeah, yes.
So,
Yes, if what?
Yeah, the none can be returned as a result or none can be used for maybe applying it in a later point of time. Certain places like we can get none as a value if we read some data or anything that has nulls and all, we can get this none as a output as well even. Okay, in both the cases. So here we are not using any files or anything. So we don't have to worry about this none with respect, but none type is there. None type represents what? It is unknown value. With me? What other type we had? Yeah. These are some of the simple data types what you are supposed to know prior hand before we go to the complex like type like list, dictionary, tuples, but list on and off we are considering. Okay, on and off we are using list, but we will be seeing that in a subsequent period of time because that complex data types will not come under the basics of Python. We are learning about basics of Python programming. Okay, operators. Operators. What is operators, guys? Operators help us doing what operations? Help us do arithmetic. Okay, that is everybody will be always remembering this arithmetic. Comparison or relational or assignment or logical. Major purpose of using operators. Almost we used all operators in our so far learning, other than one operator called logical operator. Every other operators we used in our so far learning. Well, let me write a simple line of code. You tell me what are all the operators we have used there. Okay. I'll write the same line of code. Okay. A equal to 10 plus 20. 10 plus 20. What are the operators I used here? Using assignment operator and arithmetic operator. Agree? Then I'm going to perform B equal to 20 plus 20. The same thing we are performing. A equal to B. What operator I'm using? comparison operator I'm using. Okay. I'm going to use what operator I'm using? Logical operator I'm using. Okay. I'm going to talk in detail about it. Just I'm directly writing the line of code and I'm asking you what type of operators I'm using. Not everybody are in a position to understand what you are using here. Unary operator we have as well, but unary operator is not good in performance, so we will not be using it regularly. Unary operator we can use only in a worst case scenario. So let's not worry about it. Okay. But what is unary operator? We'll be using in our looping constructs, conditional structure and all in certain cases. Okay. That is relatively bit complex to understand, but we don't use that as well because it will do a byte by byte comparison. It won't do a block by block comparison, it will do a byte by byte comparison. Okay, fine. So these are all the regularly used operators we can consider. Okay, what are the regularly used operators? Assignment, I mean, there are a lot of other types of operators are available, right? Like unary operator or maybe like binary operator, like this and all is available. But these are all the regularly used operator. We'll go with this. Okay. So I'm just creating some variable and I'm assigning a value to it. So we call it as an assignment operator. I'm creating a variable and assigning some value to it. While I assign the value, I'm performing some arithmetic operator of plus or minus or whatever we are doing. Ternary operator, yes, ternary operator is there. Those are all, when do we go? Particularly when we have maybe a byte by byte comparison, especially on the binary data set, we'll go with the ternary or the unary operator and all. Okay, however we use them, but not in the name of this operator we are going to learn. We will be apply that wherever it is needed. Maybe especially in this conditional structure and all, we'll be applying. Okay, fine. Especially I may be asking you to apply that unary and the ternary operator in this conditional structure as well for you guys. Maybe some of this program that I have given here, right? Here I'll ask you to use this operator, unary and the ternary operator, by giving you some examples. Not as such operators I'm going to talk over here. Okay. So assignment operator. I mean, maybe we understood about the assignment operator and the arithmetic operators are performing over here. What are the arithmetic operators we have that we see separately, right? That is in our documentation. I'll go and talk. Plus, minus, division, modulo, all these are arithmetic operations. But as such, you have to just see this and say, oh, this is this line of code contains, this expression contains, yeah, assignment operator, equal to is an assignment operator, plus is an arithmetic operator. Okay. Or I'm going to say, here also we have both assignment and an arithmetic operator. This is also arithmetic come assignment operator, but we are using maybe a special formatted option over here. Keep it aside. Let's not get confused, but this is also equal to an arithmetic come assignment operator. Some nitty-gritties we'll see subsequently, but fundamentally, comparison operator. I'm going to do a comparison between A and B are same or not. A is going to have 30, B is going to have 40. So when I compare, it is going to return what as a result? What as a type? Boolean of false it is going to return in this case because both are not same. So we can operate across the types, across the data types. We are having data types used here, right? And then we are seeing the data type that is returning here as an output of this comparison operator or a relational operator, we call it in any name. We can able to find the resultant output in a binary in a Boolean format. So we are doing a comparison here. The 2 equal to represents comparison, 1 equal to represents the assignment. There is a small variation between this. People used to mistakenly use this alternatively. Okay, be very clear. 2 equal to represents It's going to be a comparison or a relational operator. The not of I'm using, that represents what? Logical operator. Logical operators are of three types in general. We have other logical operators also available, but mainly and or not. With this and or not, we can achieve most of the functionalities. Okay, so let's go back and see here, right? So basically what you guys can do is you can follow the code also, but you want to learn simply this concept first in this terminology what I'm using. You can go and just try this out first of all, right? Just by using this simple functionalities what I've given, then you guys can go and try the actual program. I always say like go with the PDF first for your fundamental understanding, and then you can go with maybe like this what to say the next level of the complete code understanding. Okay, take it in that way, guys. Okay. So operators we were looking into. Operators majorly is of 4 types, but we have around like 8 or 9 operator types available in every programming languages. It's common for every programming languages. So arithmetic operator, if you perform some arithmetic operations, or the relational operations, which is more used for relating something, comparing something. Logical operator for doing a multiple levels of comparison. Perform a conditional operations on the variable. Like first, this maybe like values has to be matched and some other set of value has to be matched. Then you go and further proceed. Otherwise, don't proceed. Or either or both, or not of that particular condition. Like this, we can use the and or not for performing some logical operation, whether we wanted to decide on where to go, here or there, where to go, we can use this logical operator by using this and or not operations. So we'll go and use all of them in our program subsequently, but let's take an example. Assignment operator, we'll take one program and think about using all of them in it. Okay, let's imagine, let's think about some scenario in that we are going to use all of these operators. By that way, we can understand what is the purpose of this. Assignment operator represents what? We can able to assign some value to a variable. At the time when you assign some value to a variable, you can perform some arithmetic operation. After assigning some value to a variable, we can do a relational operation between the variables. After performing relational operation, we can perform logical operation on that relational operated variable. So the connection will go like this. We create an assignment operator first to assign some value directly or some arithmetic operated values to a variable. Then that variable comprised of arithmetic operated value can be related. That related values can be logically operated. So what does it mean, right? First, we are going to do an assignment operation. So these are all just an example of like what operations we are performing. Maybe if you wanted to marry all of them, right, by saying, let me do assignment operator, then arithmetic operator, then relational operator and logical operator. I'm going to do all of them together. Relational or comparison, you can call it in anything, both are same. And logical operators. These 4 operations you guys are going to do. So assignment operator represents what? I'm going to assign some value to a variable. For example, a equal to 100. We are going to perform some operation related to maybe like greatest of 2 numbers. Let's take it as an example. Okay, find the greatest of 2 numbers. It's a very simple program to start with. Any of your programming knowledge is related to all these operators come conditional structure. Okay, so find the greatest of 2 numbers. Okay, 1 second. Please. Greatest of two numbers I want to calculate. So I'm going to assign a variable a equal to some value. So this is an example for assignment operator. B is equal to some value plus some other value that I don't know right now. So I'm going to get that derived from somewhere. So input of, I'm going to get some other value. And these two comprised of what? Assignment operator come arithmetic operator. Then I'm going to perform a relational operator. If in a conditional structure, I'm going to do that. If A is greater than B, right? This is what type of operation I'm performing? Relational operation I'm performing. Maybe like I don't have an option for adding something like a AND condition over here. Okay, or condition I'm going to write. Or A is equal to B. So I'm doing two operations here. If A is greater than B or A is equal to B, then you go and type something like print of. I mean, this is not a complete solution for what we are trying to achieve. Like A equal to B means it has to be treated separately. But I'm just comparing in one shot whether if A is greater than B or if A is equal to B, then print A is greater or equal to B. Any one of this case may occur. I'm going to put an else statement directly by saying print B is greater directly. I'm deciding on it. So we are doing all the operations in this one simple program. What all the operations we are performing? Assignment operator. Then arithmetic operator. We are doing some operations here. Arithmetic operation. Anything you can perform. Then relational operation. Comparing whether A is greater than B or A is equal to B. These two are equal to or greater than is a comparison operator or is a logical operator. I'm checking whether either this matches or this matches. Any one of this match means you go to this or return the true and go inside this if block. If both of them are not matching, when it won't match. If B is greater, then both of this condition will not match. Any one of this will not match even. Then I'll go inside the B is greater and print it. None of this matches, then I'll go to B and print it. Right? So these are all the operators we are using in one simple program. Greatest of two numbers I want to calculate. I'm using all the operators in one shot. So let's go and see here. So see directly the input is taken when I copy and paste, right? So if I copy and paste all these lines, this if condition is taken as an input for B. So we are supposed first set B. B is equal to 40 I'm setting, right? So 50 plus 40, 90 will be stored in B. Now I'm going to compare. If A is greater than B, yes. So it will go inside this direct print statement and print. It won't even go to this OR condition and check at all. Directly A is greater than B. So it is going to directly print like saying A is greater than or equal to B. Then the second case, I'm going to again run this. I'm going to give something like 50 for B. So 100 will be coming. Now I'm going to say what it is going to print. It is going to print equal to B. A is equal to B. A is equal to B because A is equal to 100, B is equal to 100. Now the third scenario. I'm going to give 60 for B. So 110 is B, A is equal to 100. Now it is going to the else case because this condition is not going to meet. A is not greater than B and A is not equal to B also. So it is going to go to the else statement and print B is greater. If B is greater than A means how to write else if. Are we learning how to write if condition or else if condition, Sundar Rajan? Or are we learning what are all the operators we can use? What is the topic of our discussion? Stay on the topic, that is very important. However, we learn about the else if or whatever you want, but we don't need else if here. You don't need else if here. You can write as well. Else if B is greater than A, that also works actually as you are expecting, but that is not our aim of learning this, right? Else if B is greater than A, then you print B is greater, but not needed, right? Why we have to go and put a conditional check and then go to this block? We can close our eyes and say what, A, else. Don't check anything further. By that way, we can improve the performance of the code what you are writing. Agree what I'm speaking, Sundar Rajan? Okay. Okay, fine. So you got some idea, guys. Like we can go with, I'm not teaching you what is if condition here. I'm teaching you what are the operators we can use altogether in one program. We'll be using some other operators in a later point of time, wherever it is applicable, because that requires a scenario to discuss. Like not directly we can apply those kind of operators and all. Those kind of operators and all, the unary, ternary operators and all used for the conditional checks. Like these kind of programs when we write, we can go and use those kind of unary or ternary operators to achieve the functionality. But that one, if we go right, then we have to first learn about what is the conditional structure, looping and check, then only we can go there. We can't go directly there. Even for this itself, I was supposed to use the conditional structure. Sundar is asking Irfan, what is else if? How can I write else if? Our aim is not concentrating on else if. Our aim is concentrating on what, if I see this program, I have to tell what all the operators are used in this program. Fundamental operators used in this program, minimum operators, right? So you are all able to understand this case. By seeing this, yes, I have assignment operator, arithmetic operator plus minus multiplication, division or power, square root, whatever. But I mean like that you can get easily. But what are the operators we have, that the classification of it? You are able to get team, right? Everyone, right? Regardless of you are a programmer or non-programmer, you wrote any program earlier or not, you are able to understand this, what I'm speaking, right? So relational operator or comparison operator and logical operator, right? Logical operator is of majorly three types, and or not. If I put a not here, what happens? If I put not here, what happens? It will negate. So there is a negation called not we have. Maybe I'll quickly show that over here to you. I'm going to check something like if A is equal to B, right? I can go and check like this, right? A is equal to 100, B is equal to 100. If A is equal to B, then you do some operation. Else like this, we can have a statement. But I wanted to perform the operation for first going to a true statement, of saying not equals. I want to ulta this print statement, but still the same order of program I have to write, but it has to be changed. The else has to have, if A is equal to B, then else has to be printed. Then what I can do for that? I can use a not function, or what I can do, I can type something like this. If A is not equal to B, I can use a relational operator itself to achieve that. If A is not equal to B, then print not equals. else print equals. Is it correct, guys, what I'm writing? The line of code? Am I writing a right line of code? Now it will print the right result. So it will say, no, it equals, because A is equal to B. Now if we go and write the same functionality by using logical and comparison, not only logical. So I can put not beforehand to say, hey, whatever you are returning true or false, if you return true, right, I'll convert that into false. So that is equal to what I'm using not equal to B condition here. Rather, I can use a not equal to B condition directly as a comparison operator or a relational operator, or I'm using the relational operator. On top of that, I'm negating. This is called negation operator. In a simple term, we used to call it as negation operator, but it's a logical operator. So I'm going to say what now? Go and print not equals or else equals or whatever you can print. It is going to work in the same way. So we are using the relational and the logical operator together to achieve a relational operator which you don't have available somewhere. For example, I'm going to check if A is greater than B. Do we have something called A not greater than B? Do we have any function called A is not greater than B like this? There is an operator do we have available? Relational operator. Let's check what it is saying. Sorry, Irfan, what is this invalid syntax? A is not equal to, we don't have. Not greater than. Not equal to we have, but not greater than we don't have. Then how can I achieve this? I got to put greater than only. Then I have to put what? Not of A is greater than B. So you are able to understand the purpose of this negation operator, especially the logical operator called not. Very, very important, right? So not of A is greater than B. That means what? A is greater than B, it will first check. No, A is not greater than B. It will return false actually as per our case. The false will be converted into true. Will be converted into true as per this code. So I have to mention equals here. Both are equal. If not greater than B means, then I'm going to put both are equal. Okay. So this not can be used in certain cases along with that means the logical operator can be used along with the relational operator to achieve some results where the relational operator does not have some features available. Some of the relational operator that is not available, that can be fulfilled with not. Okay. We can't compare both greater than or less than at the same time. So we have to marry them by using this operator, what we used here. Greater than, we can't check at the same time. Equal to, we can't check at the same time. Or maybe we can check this one at the same time, right? This operator, we can do what? A is greater than or equal to B. Rather than writing like this. Like this works. But A is greater than or less than B. These two conditions we can't check at the same time. So then what I am supposed to do? A is greater than B or A is less than B. I have to go and use the OR operator to compare both. Saying like either A is greater than B or A is less than B. Then you go and run this condition for some reason I need. Like this, we can use this comparison and the logical operators right here and there in multiple ways to achieve broader result. That when you require some logic to be derived at that time, we can use it accordingly. It's not like all of a sudden we can just take this and discuss. Even though if I discuss with all permutation combination, you could not able to maybe like recall that again. But try to understand the way how and all we can use them. So or I'm using here, or and I'm going to use. Which one is more meaningful? Which is more meaningful, guys? If I use and or if I use or? Why I should not use and? That is where our brain will think about the logic. That is where we have to put our thought process. The A can be either greater than B or less than B. Both can't be possible. Both can't be possible. So I got to put R here. R here. Then when do I put and here? In what situation I can put and here? If I want to check if A is greater than B, right? Even one more variable, obviously correct, but I want to just do some quick operation. A is greater than B and A is equal to maybe like 100, or A is greater than B and A is greater than 50. Then you go and run this like this. I want to say, or A is greater than B and A is less than 60. For example, A is equal to 50, B is equal to 40. If I assign something like that, it will work. You see here, if I'm going to have A is equal to 50, B is equal to 40. Will this if condition works? It works. Right? So you can introduce one more variable. If I'm going to do a comparison of 3 statements, then obviously we'll be using and condition. If A is equal greater than B and A is greater than C, then A is greater than B and C. So I have 3 operators over here. A, B, C, 10, 20, 30, or 30, 40, 20, 10, 30, something like this we have. I'm going to put a condition. If of, we can put bracket, which is optional. If of A is greater than B, and I'm putting and here, and A is greater than C, then print A is the greatest number. Here, and is meaningful. I can't put R. So we have to know accordingly how to use and, or, and not. We can play around with that, right? So that is where the regular practice of your programming will get you some idea, but fundamentally concentrate on these 4 types, guys, 4 operators. We have few more nitty-gritties to add that will be subsequently added. Okay, in the respective programs, respective case study, we add that. Okay, so now where we are over here. So you got some idea about the operators, guys. Operators. We know about this earlier itself, even I would say. Without learning this, you know what is an operator, or I mean, not what is an operator, what are the types of operators you don't know. Maybe you could not able to recall. But we have used this in our life regularly. Our brain always used this. Right? Our brain used in what way? So our brain always use for assigning something in our mind. Okay, what is the bank balance I have in my bank? I'll have that in my mind. I have 1 lakh rupees in my account. Okay, if after I get the bonus, I'll be getting 1,30,000 rupees in my account. Okay, I'm planning to purchase a bike. If the bike price is greater than, if the bike A is greater than whatever the amount that I have, if a bike rate is greater than whatever the amount I have, or the bike price is equal to whatever the deposited amount that I have in my account, right? I'm not going to buy that bike, or I'm going to buy that bike. Maybe like I can take it in the other way. If the amount in my hand is greater than the price of the bike, or if the amount I have in my hand is equal to the price of the bike, I'm going to buy that bike. Like our brain will put all this calculation in general. Agree, team, what I'm speaking? So these are all we are already aware of, already we are accustomed to it, but we are learning something formally over here about the operators, what we'll be regularly using. And there are some special operators, like how complex data types we have, we can use in that way some of the operators in the respective place. Okay, done. Modulo, yes, 10 mod of 100, 10 mod of 2 will return 0. Right, Harish? 10 into 2, 10 into 2. What does it mean? 1 into multiplies 10 into square root of, right? 10 power of 2, 10 power of 3, 10 exponent of 3, sorry. Right, like we have lot of symbols available. Use it accordingly, the mathematical symbols. Right? So it's a placeholder for us to say, I mean, like if I find some operators like this is falling under arithmetic, relational, logical assignment. Okay, that is our learning. But we may be using any number of operators, depends upon the need, depends upon the use what you are doing. You can identify what are all the different operators, huge set of documentations we have. Right, we can't remember all of them. We don't have to remember all of them. That's what I'm telling. Otherwise, you'll start feel the complexity. Hey, should I have to remember all this? Not everybody take it in the same way. Like if I show something additional related to the different operators, even ternary or unary operators and all, if we discuss, right, then people will feel a complexity. But this one will give them some idea of starting their learning actually, right? That's the reason. So you can go with other operators, but you may be using, but you could not able to recall all of them. Okay, with me, guys. Okay. Built-in functions, again the same case. You have n number of functions available to operate on the string or numbers or maybe like float or everywhere. Maybe we can take something like the name equal to or employer name equal to Inceptus Technologies. I can perform n number of functions on top of it. Okay, n number of methods I can apply on top of it. So employer name dot, when I type, it will show me all the options what I can apply on top of it, all the methods I can apply on top of it. M represents method. Method or function almost similar. Okay, I'll talk about the difference between the functions and method more in detail later, but methods or function both are almost you can consider as a similar component. Some functionality if you want to achieve, apply. Some methodology if you want to apply on some data, you can use the functions respectively. You have this many number of functions available, the methods that is available to support you to apply on this type, on this variable. So how do you learn a function? How do you understand a function, basically? So when you go here, and I have some variable assigned in a REPL, right? Employer name dot. When I type tab, it will expand me all the possible functions that this set of library supports. Where these functions are coming from, where these functions are populating from, especially when I type dot, it is populating from somewhere. Where it is populating from. If you guys remember, when you go and set up your project, in the current project of whatever we have set up, WD32 project or wherever, you guys found some virtual environment path, V environment, VENV. You remember? You guys were asking, hey, VENV, I was able to see. I told, don't worry about the VENV. Basically, the virtual environment will be set for the entire, my entire PySpark, PyCharm IDE, once for all, which contains all the libraries, all binaries related to the Python program. Currently, what you guys have is only Python related libraries available in that virtual environment. If you guys go and try some functionality like from PySpark.SQL import some library like this, if we type, it won't come for you. But for me, it is automatically popping up and showing, hey, Irfan, what you want to import? You want to import SQL context or Spark session or Windows specification or Pandas related functionality or UDF registration? What you want to do? Tell me. I can give you these classes, these programs for you. Like this, I'm just talking about it, Vignesh. Wait for a while. Listen to me, right? So it is showing me all these libraries are available. For me, it is showing. For you guys, it is not showing. I'm going back to our installation. So listen to me carefully. I'm not talking something new here. We are supposed to complete some part in our installation. So when I type something like from the PySpark package, from the SQL subpackage, we have a session module. There is a session.py module we have. Right? In this module, we have multiple classes, multiple programs available. Can you help me import the Spark session program from there? Like this, I'm telling. It is not throwing error to me. But if you guys try this in your PyCharm IDE, it will throw an error. Sorry, what is PySpark? I don't know even. Like, I have a lot of functions that is available in this environment from where it is popping up. Like we right now, all of us have Python related functions available, but Spark related functions nowhere available for you guys, because in this IDE, in this virtual environment, you did not configure the Spark related libraries yet. Okay. The virtual environment, when I created a project, the virtual environment is not created for me. The reason began, for the first time when I create the project, the virtual environment got created. You can see this blue color symbol for this project alone, because this contains virtual environment. So you can go and expand here and see the V environment is configured. It contains all the libraries, all the binaries, the Python 3.x libraries are available here. All the Python related libraries are available here. Inside these libraries, we'll be having all the related functions that is available. The Python core libraries are there, or the Python PySpark libraries are available for me, but for you guys, you don't have. So when I type from PySpark.sql, which is mainly we have to do before you write a code. You remember I told that PySpark.sql.session. When I type like this, where it is going and taking that session file. The session file contains all the programs. So it is going and browsing this PySpark in the Python module. I have PySpark module inside that. Sorry. In the SQL module, inside that we have the session.py file. So it is going to PySpark.sql. It is going and getting the session.py file. From the session.py file, if you go and see, you have a program called Spark session class. This class. That class I'm just importing here. Same way, I'm closing this file and all, right? So what is the purpose of this virtual environment that you got in your project? You were able to understand. I got Spark installed. How did I install Spark? I'm going back to our installation. If you remember this one, you guys were asking, Irfan, do you want me to install this? I told, wait guys, don't do this now. I'll tell you later when we go to Spark. Right now we are going to only learn Python, so no need of doing this for now. Getting some clarity. When I do a Python installation package install of PySpark with a version of 3.1.1 or 3.1.2 or whatever the version, 3.2.1 or whatever the version, it is going to pull the PySpark related library from the internet, and it is going to add that over in our virtual environment like this in our library path. Following me, team, what I'm speaking. So now when I type a function here, The related function, something like capitalized function, what the capitalized will do, guys. Looking into the function itself, you can say to some extent what this function can do. So if I put a capitalize on top of it, it will just do an init cap of the value. So it is just capitalizing this value. Like we have multiple functions available. So where is this function is returned? In the built-ins.py module of our Python library, we have all these functions returned. Very, very important part of our learning. The function-based programming, we are right now just tasting it. We are not really learning. There is something called a built-in library that is available inside the Python cache memory. Like this has been loaded into our cache of the PyCharm ID. When the PyCharm ID is opened, you guys were finding some performance degradation, right? You are finding some performance lagging. I'm seeing like slowness in my computer. Why? It uses some RAM memory. In that RAM memory, in that memory, the PVM will be created. That PVM will help you run these programs and all. That PVM will hold these functions, capitalized function, case fold function. And they're telling what, hey, this function will return a capitalized version of the string what you're passing. That is, make the first character to have an upper and rest of all as a regular lower character, the capitalized function. So there are n number of functions like this is being given to us, right? It is being totally maybe did what with respect to they have made a what to say like abstraction on top of this capitalized function. So when I go to this capitalized function, and when I see where and all these capitalized functions are being used, we are able to find the core module 1 what we used. We used capitalized function. Here we use capitalized function. In W41 we used capitalized function. So leave that part. I'm going to talk with you guys about, hey guys, what are some of the built-in functions we are going to apply in this variable. The variable can be applied with some built-in functions. For example, I'm just again talking about what is a function-based programming. Finding the greatest of two numbers. We have to write how many lines of code? I want to find the greatest of two numbers. I at least wrote 3-4 lines or 6 lines of code, right? I want to achieve that maybe like result, greatest of two numbers or greatest of 10 numbers. Greatest of 10 numbers, how many lines of code you have to write? Very huge set of line. Agree, team? It requires huge permutation and combination. Not just like that we can get. You have to put 10 to the power of 9 iterations you have to put, not to the power of 9. 10 into 9 iterations you have to put. That many number of combination you have to go and check. Okay, I want to achieve the same functionality of greatest of two numbers in one line. Can I achieve? I have A equal to, or A comma B equal to 10 comma 20. I want to find A is greater or B is greater. What I can do? I can go and find the max of what? A and B. How can I find max of A and B? I can use a function, there is something called max function is there. I'll go and convert this A and B into a list. Is it giving me the greatest of two numbers? Just I use a function, a built-in function to achieve that. Now you tell the function-based programming means what? We have a lot of built-in functions to achieve some functionality. That is called function-based programming. We are entering into function-based programming, so we can avoid doing some boilerplate coding, what I told today morning. Python is a high-level programming language. We can use high-level programming like this. Even you go low level, that low level is not so much boilerplate. It is allowing you to write some custom functionality. Like this one will give you only the greatest of two numbers. But I want to write some custom functionality like what I wrote here. Something like this additionally I wrote, right? That and all I can't write over there. Okay, keep it aside, guys. So the functions are going to help us achieve some functionality. There are built-in functions available. How can I go and understand these are all the built-in functions that is supported for this string type that we have to first realize. So when I put dot, it will help me show all the list of functions, whatever this employer name supports, this string supports. I can type the respective function and leverage it if you know directly. Capitalize, we thought it is going to create an init cap for all the string that I'm using, but it is not doing in that way. For that, we have some other function available. Something like maybe called the header function. So if you see here, we have some function called something like is title or title function. We can make it as a title. In that case, not a header, title function. The title function will say what? I'm going to convert it into a title. Here we are finding what? We are finding init cap completely. But whereas in the case of capitalize, it will do only first character as whatever the uppercase it is creating. How do we understand these functions behave in this way or that way? So when I type dot, it is expanding all the possible functions. So I can type enter. What is the capitalize of self inside that? I'll talk about it subsequently. Wait for a while. So I got a function applied. What is the nature of this function? I want to know. I will simply go and hover my mouse, take my hand. It will show me the short description of this function, what this function is used for. By understanding this, see, somebody can remember some of the function. For example, I told, rather than title, I told header. Because not everybody can be able to recall all the functions, but no need to recall. That is what I'm trying to convey. What you have to do, as per our need, we have to check for what all the possible functions are there. Maybe we can go to the Python documentation to search also. See here, docs.python.org. If you go there, you can able to see the entire comprehensive list of all the functions, whatever is supported in this given version. And you can go and make use of that respective functionality. But shortly, I want to quickly understand. I want to just perform some operation, like I want to swap the case. So what are the case related functions that we have? So we can write the functions accordingly. It is in a lower case. I want to make it completely into an uppercase. Change the case. Maybe I have some string like this. I want to swap the case. So the case will be flipped. Like I want to use multiple functionalities. I can use my thought process to put some English term what I use for applying this functionality. Capitalize means I'm going to create a capital case or title swap case. So accordingly, the regularly used function will come in the top. Format function, you remember? We used to pass the arguments to the formatted string to get it applied. You remember? So the format function is used in print statement what we use, but we can apply that format function over here to say Inceptus Technologies, maybe like 0 and 1, I can mention like this, right? You remember? So I'll say 0 and 1 of private limited. So Inceptus Technologies private limited will be printed. So like different functions we have available, what I'm trying to convey first thing is, when you use a function, you go and hover that to understand what function is this. If you want to go and understand in detail about the code, how they have made this function, you can click on the control button. It will create a link for that original code what they developed. You can go to that code. In this code, you can understand not the actual source code. For this, we have to download the original source code of that program. We can see the source code also, but they have not given the source code. They have given you only the highest level of wrapper of what this function will do, simply we can understand here also. And when you go and click on this function with a control, it will show where and all it is being referred, in what are all the places this capitalized function is being used. When it will be useful for us in a later point of time, when you go and develop some function-based programming, reusable frameworks, some generic frameworks when we develop, we'll be using this functions to identify where and all we use this function. For example, I developed some function for this retail project. Common utilities I created here. So this common utilities is used in which are all the module of my program I can able to understand. In my project, I used in the driver module. In the driver module, I used this write RDBMS data function. It's not only applicable for built-in functions, for our custom functions also it is applicable. So we are going to develop functions in our learning as a framework for developing the framework. Very, very interesting part of our learning. So these are all built-in functions. So how do you understand a built-in function? I'm just capturing how to use built-in functions. Is depends upon the need. Right? Type dot function name over your mouse to understand the description of the function. Then type function name, press Control plus mouse click to see the source code of the function and the description. Source code is not exposed means abstracted source code at least. Abstracted means the source code is not given to us. It is abstracted. Right? Click further, Control plus click further on the opened function to understand which are all the programs referring to it. Following me, team. Good to know or not? Is it good to know before we learn about some functions? Our aim is not learning. Depends upon, depends up to the need. Very importantly, no need to remember or recall all the functions. Very important. Don't try to learn, read, remember, mug up. Don't do. Okay. Certain functions we naturally use. I'll continue on this tomorrow. Okay. With me, team. With me. So consider all these factors. How to do this, you just go and try. One function you take. We'll talk about how to understand a function. That is yet to be there. How to understand a function. Understand a function. See, function I'll use interchangeably. The method or function I'll use interchangeably the name, but method is a function is a method. You can consider like that. Okay. With this part we'll discuss tomorrow. Okay, team. Please go through till this part of day 4, right? And come back, guys. Okay. Complete then and there. We'll start day 5 from here. Okay. Any questions, team? Day 5 will start from here. Otherwise, thank you, team. Have a good week ahead. Thank you all.
Yeah, Irfan, you have given in the line 277, right?
Yeah.
Yeah, in
Yes.
subtest technology, flower base 0 and flower base 1, right? Yeah, actually, yeah, that will be considered as a string throughout, right? Actually,
that will be considered as a string. Yes, obviously. That will be considered as a string.
Okay. Okay. So you want to print as 0, 0, 1 as well. Actually, no. Previously, we saw a concept like 0 will be assigned for inceptors and 1 will be assigned for technologies, right?
No. See, basically, I'm going to print something like this. Print Inceptors Technologies Private Limited. Okay. I don't know whether it is a private limited or it is a public limited or it's a maybe like what to say, like individually owned. Okay. So I'm putting a placeholder here. I don't know about this value. Got it?
Okay.
Got it? Now I'm going to say, hey, this variable I'm creating the company name equal to so and so. I don't know this value of the $0 and $1 right now. I'm going to do what? Company name dot format. I'm going to apply a format function. Format is a function used for formatting or furnishing this value later. This is a format of first parameter will go to $0. Format of second parameter will go to the $1. So private limited I can put or public limited I can put. Clear?
Yeah.
It depends upon what you are getting later point of time. For example, you are going to format function. We were just using this for printing, right? Print of format we did. That's it we did.
Okay.
So this is a function that is applied on the string data type, but we can use format function to do some formatting at the time of printing. Clear?
Substituting the values. Yeah, clear this one.
Clear? Yeah. Okay. Yeah, great. Any other questions, team?
Irfan, I have in text pad you have asked us to try something like regarding that data.
No. Sorry. Can you please repeat from scratch? I was not able to hear you clearly.
Okay. In the text pad, you asked us to try something, right, from the data frames and all. So you asked us to execute.
Yeah. The use case, right?
Yeah, correct. Yeah. That one I am executing. In the fourth point, you have mentioned curation process with the rejection strategy. So while executing the SQL query, I'm just getting some exception or error response.
Which query?
Let me ping that in the chat.
Yeah.
This one, the error also will ping.
Right in the JSON format to a location, right? Yeah. What error?
Let me ping also.
Yeah.
Something, it's like it's not the valid view, it's not created.
1 second. World view. Yeah, you have missed to do. Maybe like I have missed to do that, right? Then.
Yes, sir. For now, you did not create a world view.
Okay. So what we are supposed to do is, So this data frame, right? What we have here. Maybe I not have captured that. It seems, right? So world view is nothing but.
Yes, you did not create it for now. You created, but you did not note it here.
It works, right? So if I put like this, this data frame dot create or replace temp view of this name if I go on view. Just add this line, I'll ping you if you are there, right?
Sure.
You can able to get this achieved. Okay, just try this. It should be working.
Yeah, sure. Let me try.
Yeah. So what is the error you are particularly finding is analysis exception, table or view not found. World view is not found. It is clearly telling that, right?
Yeah, yes, for now I can able to, I think, it's working fine. Perfect. Yeah. And also, I just want to connect with you personally, Irfan. So, is it the right time, or else I can connect after some time?
Maybe like after this. I mean, after we close this, right? We can talk over the phone.
Sure.
Okay. Yeah. Fine. Anything else, team? Okay. Thank you all, guys. We'll meet tomorrow then. Thank you all.
Thank you.